So far, our discussions have focused on head-on collisions, or collisions in one dimension, since the objects move on a straight line both before and after the collision. However, collisions often occur in two and even three dimensions. Consider, for example, a system of two objects that collide on a horizontal surface. The weight of each object is balanced by the normal force from the surface, so that the net external force on the objects is zero, and the total linear momentum must be conserved. The figure shows an overhead view of the velocities of the two objects both before and after the collision. And we know that the total momentum right before the collision must be equal to the total momentum right after the collision. However, we must remember that momentum is a vector, and in general it can have both x and y components. This means that the total momentum must be individually conserved in both the x and y directions. In other words, we write the vector equation for momentum conservation in terms of the x and y components. Looking at the figure, we can see how the velocities of the objects before and after the collision are resolved into their components. These can be substituted into the conservation equations above and then solved for unknown quantities. In this example, we have considered a system composed of only two objects. For each additional object added to the system, another mass times velocity term must be added to each side of the conservation equations.